Assalamu alaikum. It's Vivian. I'll be explaining you Chapter 9, Alcohols, Part 2. Let's start first of all with our objectives. Our objectives of this lesson are two. First of all, you have to recognize the physical properties of alcohols, and second, you have to explain the effect of the presence of an electronegative element in alcohols on their physical properties. Let's start first of all by a recall from the previous lesson, which is part 1. We know that monoalcohols are organic compounds whose molecules contain one hydroxyl group linked to a carbon chain, and we know that the general formula of a monoalcohol can be represented either by ROH, which is the most general that fits all monoalcohol, or by CnH2n plus 1OH or CnH2n plus 2O. Now let's start by our first objective, which is about the physical properties of alcohols. Actually, we have to study two physical properties, which is about the density and the boiling point. Physical properties of alcohol depends on the presence of hydroxyl group. This is normal because the hydroxyl group is their functional group, and the functional group it means it is the reason behind all physical and chemical properties of a chemical family. Now the density of alcohols, of all alcohols, are measured by scientists, and it is found in general that alcohols have a density that is around 0.79 gram per centimeter cube, or when we convert it to gram per meter cube, it is about 790. Now these values are not to be memorized, but I will advise you to memorize it for one reason. In exercises, when you have to find or to deal with densities of alcohol, and when you have to calculate it, the number you will get, it has to be almost around these. So this number would be a reference for you to make sure that the numbers you can get upon calculation in an exercise is logic or not more. Now in chemistry, there is a fact related to the boiling point that the molar mass of a molecule, when the molar mass of the molecule increases, the boiling point of this molecule increases. In alcohol, as a consequence, as the number of carbon atoms in the molecule increases, the boiling point will increase too. Look at this example. Consider here methanol, which is CH3OH containing one carbon atom, and ethanol containing 2 carbon atoms. The molar mass of methanol is 32 gram mole minus 1, and that of ethanol is 46 gram mole minus 1. So as you can see, the molar mass of ethanol is greater than that of methanol. Now look at their boiling points. The boiling point of methanol, it is 64.7, that is less than that of ethanol. So this goes perfectly with what we have said here, yes, that as the molar mass of the molecule increases, the boiling point of this molecule increases. Now let's take this example. Let us compare the boiling point of ethanol of molecular formula C2H6O and that of its corresponding functional isomers, which is ether C2H6O. Look, this is ethanol having the structural formula with hydroxyl group as a functional group, and this is ether. Ether is a functional group of ethanol, so they have different functional group, but definitely they will have the same molar mass since they are isomers, so they have the same molecular formula. Now look at their boiling point. That of ethanol is 78 degrees Celsius. It means it's liquid at room temperature. That of ether is minus 24 degrees Celsius, which is gas at room temperature. Now, their molecular mass or their molar mass is equal, but the boiling point of ethanol is much greater than the boiling point of ether. How can we explain this? Although we said in the previous slide that as the molar mass increases, the boiling point increases, here these two compounds have the same molar mass. In reality, there is another factor that affects the boiling point. What is this factor? It is the hydrogen bond. So the reason behind this difference in the boiling points is the existence of hydrogen bonds in alcohols and not in ether. What is hydrogen bond? As mentioned before, the physical properties of alcohols depends on the presence of hydroxyl group. So alcohols show what we call hydrogen bonds between them. Hydrogen bonds is an intermolecular bonds. What does that mean, intermolecular? Look at this. It means it is between two separate molecules. Look here. This is ethanol molecule. It is one molecule. And this is another ethanol molecule. Within the same molecule, there are covalent bonds. These covalent bonds are intramolecular. It means they are in the molecule itself. But between this molecule and this molecule that are separate, there is here what do we call the hydrogen bond. So this hydrogen bond is between two separate molecules, and this is why we said that it is intermolecular bonds. Here is another drawing for methanol, and this is hydrogen bond that is between this molecule and this other molecule. I repeat, it is an intermolecular bonds. Now, how hydrogen bond is created? Look how. Oxygen element in the hydroxyl group is highly electronegative. What does highly electronegative mean? It means oxygen has high tendency to attract electrons toward it. So the other way around, the electronegativity of hydrogen is very weak. So in hydroxyl group, which is OH, the electrons shared in the single covalent bond are more attracted toward oxygen. Which molecule I'm talking about? This single covalent bond where two electrons are shared between oxygen and hydrogen. As a consequence, hydrogen will have what do we call partial positive charge, and oxygen will have a partial negative charge. What does that mean? Look here. This is oxygen. Oxygen here, inside this molecule, it has what do we call partial negative charge. What does that mean? It means it doesn't have a whole charge. It has a little bit negativity due to the attraction of the electrons in this bond. And oxygen will have what do we call partial positive charge due to actually to the attraction also of oxygen to these electrons. Now, as you know in physics, between the partial positive charge of H in a molecule and the partial negative charge in oxygen in another molecule, an electrostatic force is created. This force is called hydrogen bond. But pay attention that hydrogen bond is weak because it is not between a full positive charge and a full negative charge. Don't forget that they are partial negative and positive. So this force is really weak, the hydrogen bonds. Now, what will happen due to the presence of this hydrogen bond? Due to the presence of these hydrogen bonds, when heating, we need more energy to break down these bonds, and this is what makes the boiling point of alcohols greater than that of ether. In summary, all what you have to memorize in this lesson is the density of alcohol that is around, and as I said, even this number is not to be memorized by heart, but it is advisable to memorize it to be used as reference in exercises. In alcohols, as the number of carbon atoms in the molecule increases, the boiling point increases, and alcohols exhibit what we call hydrogen bonds that lead to the relatively high boiling point. So this is what we have to memorize, because you will not be asked in details about the hydrogen bond and how it is made, but you have to understand it, and this is why we explain it in this video. Now, this is what you have to do in the agenda. Thank you for watching, and see you in the next part.